Hello. So now we're gonna do, I'm gonna introduce the quadratic formula. We're gonna state what problem it was designed to solve, and we're gonna show how to derive it, and we're then gonna talk about some of the implications of the quadratic formula. Let's begin. So the first thing is, what was the quadratic formula designed to solve? So if you look here, we have the a quadratic ax squared plus bx plus c equal to 0. And it is this problem that the quadratic formula tries to solve. And in fact, as you may or may not know, the quadratic formula is the following situation. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? And this is the quadratic formula, and it's designed to solve this problem. That is to say, if you have a quadratic that looks like this with a, b, and c numbers, then this x will make that expression equal to 0. So now, what I'm going to do first is I'm going to derive it for you. Okay? This is going to be an example of completing the squares. Let's do that together. So if you recall, we know that we complete the square using the following technique. Well, in fact, because we're going to be doing it with this, let me, instead of using a here, let me use a letter that we're not using in our variables. So let's say if I had x plus some number k squared, we know that it's going to be equal to, okay, we know that's going to be equal to x squared plus 2kx plus k squared. Okay? Okay. So now once we're here, we know that when we're going to solve a problem like this, what we're going to do, let me copy it here so I can do the algebra. Ax squared plus bx plus c equals 0. We want, in this case, we want to match the first two terms with the first two terms here. But we already ran into a problem. This has no a. This one has an a in front. This leading coefficient. We need to get rid of it. How are we going to get rid of it? We're going to factor it out of the left-hand side. So what do I mean by that? I mean, I'm going to put a open bracket. Okay. I know that a times x squared will give me ax squared. Now, what times a will give me b? Well, plus b over a x. Because if I multiply a times b over a, the a's will cancel, and I'll be left with plus bx. In a similar way, a times c over a would give me positive c. Okay? So in other words, if I multiply a times what's inside the parentheses here times each term in the parentheses, then I will recover my original quadratic. Okay? By the way, I call these brackets parentheses. I don't want you to think that was an oversight. Mathematically, they're gonna be treated just as parentheses in the context of like solving equations and stuff. It's different when we're talking about intervals. There's a distinction, right? There's a clear difference between parentheses and brackets. But here, sometimes I like to use brackets because they help to punctuate the algebraic expressions, and whatever we can do to make the algebraic expressions more clear and more legible and more easy to manipulate, and the less likely we have for making mistakes, the better. Anyway, so now with that behind us, what I want to remember, what we're going to do to when we're completing the square. Well, I want to match these two terms with these two terms here, right? Or to put it in words, what value of k will make it so that x squared plus 2kx over there will equal to x squared plus b over ax here. And we can see that that will occur if and only if 2k is equal to b over a, like this. Now, so therefore, I'm going to divide both sides by 2 to get the k. Here, I'm going to be left with just k. But then it's going to be this divided by 2 which I can rewrite as 2 over 1, right? Because so now we know that when we divide by a fraction, we multiply by the reciprocal. So we're going to be able to write this as b over a times 1 over 2. Now I can multiply those as fractions. So that's going to give us k equals b times 1 will be b, a times 2, which will be 2a. Okay? So now we know what our k must be in this expression. Let me summarize that here so that we can continue doing this development. Okay? We have just seen that as far as this consideration is concerned, k is going to equal b over 2a. Okay. Moreover, let me take this moment to calculate what the k squared is going to be. So my k squared is going to be b over 2a times b over 2a. We know that b times b will be b squared. We know that 2 times 2 will be 4, and a times a will be a squared. So we can conclude that k squared is b squared over 4a squared, and we know that 2k, by the condition under which we got k, the 2k has to be the b over a here. And so now we're in a complete position to write down the final statement that we're going to need over here to perform the completing the square over here. So x plus b over 2a, when I square that, I'm going to get x squared plus b over a times x plus b squared over 4a squared. Okay? Okay, perfect. And what I want you guys to realize is that I now have what I was looking for, right? I wanted to get this part here, the x squared plus b over a x. So now we're going to isolate it by subtracting the b squared over 4a squared from the right hand side to the left hand side. In other words, I'm going to write it like this: x plus b over 2a squared minus b squared over 4a squared is going to equal to x squared plus b over a times x. Okay? Okay. So now we're in a position to replace this term here by this left-hand side expression. And by the way, guys, I want you to know that I know this calculation looks complicated, but if you focus on the details and take your time, I'm sure that you guys will, number one, understand it, and number two, you'll see that it's not as complicated as it looks at first go. Let's continue doing it. Let's continue. So I'm going to put my a out here, right? I'm going to open up my bracket, and I'm going to put that in here. X plus b over 2a squared minus b squared over 4a squared. That's going to replace this piece. Then I bring down my plus c over a here. Then I close my bracket, and I know that that equals to 0. Okay? So we have just accomplished what we needed to accomplish in order that we could in order to complete the square. So now what I want you guys to observe is that we want to combine these fractions. So let's do that down here. Okay? Negative b squared over 4a squared plus c over a, right? We need to get these two fractions to have the same denominator. So I'm going to multiply this fraction by something that will allow us to have the same denominator so we can combine them. If you notice, if I multiply this bottom by 4 times a, I'll get 4a squared. So I'm going to multiply the top by 4 over a and the bottom by 4 times a. I'm going to multiply the top by 4 times a and the bottom times 4 times a. Now, I want you to stick with me here. negative, I'm sorry, yeah, I'm going to copy this over. Negative 4, whoa. Negative b squared over 4a squared, right? Plus 4 times a times c all over 4a times a, that's 4a squared. Now, look at this. I can combine them. Boop! So this is negative b squared plus 4ac all over 4a squared. Okay? So now in the next line, what I'm going to do is I'm going to put this there. Okay. So this line is going to become a times x plus b over 2a squared minus, or we could say plus negative, well, let's do it as individual pieces. But you're going to see that when we put it on the other side, it'll make more sense. So minus b squared over 4a squared plus 4ac over 4a squared. Okay? Okay. And that's going to still equal to 0. So let me make room here for that. So I could have combined it the way I had it on here, but I decided that we'll combine it when we get it to the other side, and you'll see that way I don't have to play with the signs too much over here. I know that this is minus, this is plus, and when I move them over, it'll become it'll become plus b squared on the other side and minus 4ac on the other side, and then we'll combine them on the other side. Okay. Now I'm going to multiply the whole thing by a. This is going to give me a times x plus b over 2a squared minus this a, when I multiply at the top, will become a b squared over 4a squared. I can get rid of one factor of a from the top and bottom. Well, let me actually write it all out for you. A b squared over 4a squared plus 4a squared c over 4a squared. Notice how this a times the a in the numerator became 4a squared in the numerator, and that's going to equal to 0. And then what I want you guys to observe is that I can cancel out. Now look, I'm only going to cancel out 1 power of a from the top here and from the bottom here, and 1 power of a from the top here and from the bottom here, so that I can maintain the same denominator. Okay? So let's do that together. And also, let me move this to the other side already. So this is going to become plus ab squared over 4a squared minus 4ac, a squared c over 4a squared. And then plus ab squared over 4a squared minus 4a squared c over 4a squared. Okay. I'm going to put my big huge line here. Okay. And I'm going to get a x plus b over 2a squared equals ab squared over 4a squared minus 4a squared c over 4a squared. Okay, I'm here. Now let's continue. So now we're here. This is the same expression that we left off at. And we recall, I wanted to get rid of 1 power of the numerator from both sides. So for example, here, I'm going to get rid of this power of a. So it'll be b squared over 4a, because this a will cancel with one of the a's in the a squared, minus 4ac over 4a. Again, the reason why I'm not canceling out the a in this second expression, as I very easily could, right? There's an a on top, there's an a on bottom, boom. I could do that. Same thing with the 4 is because I'm trying to make sure they have the same denominator because I'm going to combine them. Let's do that right now. So now here I have a x plus b over 2a squared equals they're on the same denominator. So I can write them as b squared minus 4ac all over 4a. Okay, this is the direct implication. Now I'm going to divide both sides by a. When I divide the left hand side by a, it's gone. This is gone. When I divide the right hand side by a, the denominator is going to become 4a squared. Okay, let me show you that here explicitly. So a x plus b over 2a squared divided by a is going to be the fraction b squared minus 4ac divided by 4a divided by, instead of writing it, well, let me write it as a. So now let's work on this right hand side. I know that I can write a number a as a fraction by setting it as the numerator and 1 as the denominator. So I can rewrite this as b squared minus 4ac all over 4a divided by a over 1, like this. Now, when I look at this, I'm dividing by a fraction that is the same as multiplying by the reciprocal. So whenever I divide by a fraction, I multiply by the reciprocal. Okay, let's do that together. That'll mean that I'm multiplying b squared minus 4ac all over 4a, the numerator times the reciprocal of the denominator, which is 1 over a, like this. And if you notice, the numerator, b squared minus 4ac times 1 is just b squared minus 4ac. 4a times a is 4a squared. So, and then here on the left-hand side, the a's cancel, and I'm left with x plus b over 2a squared equals b squared minus 4ac all over 4a squared. Now what I'm going to do is I'm going to take the square root of both sides. Okay, so that's going to give me x plus b over 2a equals the plus minus square root of b squared minus 4ac all over 4a squared. Okay, now if you notice this number on the bottom, okay, it's positive, and so I'll be able to, I don't know what's going to happen with the square root of the top, but I know the square root of the bottom can be taken out. Okay, so I can see that this is going to break down into plus minus the square root of b squared minus 4ac over 2a, because 2a is the square root of 4a squared. Okay, and now I'm almost done getting the quadratic formula. So let me get rid of all this. Okay. All I have to do is subtract the b over 2a to the other side. So I get x equals negative b over 2a plus minus the square root of b squared minus 4ac all over 2a, and then we can combine these because they're fractions with the same denominator, so I get x equals negative b plus minus the square root of b squared minus 4ac all over 2a. Okay, there we have arrived at the quadratic formula. Okay, okay. And so what we have just seen is that if we start from an equation like this, if this is your equation, ax squared plus bx plus c equals 0, then the x that make this equation true are the x that are given by this formula. And there's at most 2 such roots. Okay? Okay. So that's our introduction of the quadratic formula. I hope you all have enjoyed it, and I look forward to seeing you again soon. Thank you.